Let's start with these client-server protocols. Most application layer protocols use a client-server model. In most cases, our PC is going to be the client, and then someplace in some magical data center in the intertubes someplace, there is a server that's sitting running some service. Well, on the client side, if we're talking about Hypertext Transfer Protocol, HTTP, probably the protocol that all of us as end users of the internet use the most often. So our client here, we use software like Firefox or Chrome or Microsoft Edge or Apple's Safari. There's also Opera browser. There's other browsers out there as well, but effectively, our client software is typically going to be one of those 4 browsers. Those browsers are programmed to speak the HTTP language that the server can then understand. So on the server side, the softwares, the big popular softwares over there are either Apache, which I think is the #1 web server software out there. IIS is probably a close second. And then Nginx, which is another web server product. It's not quite as popular, but a lot of the big players that have massive websites are using Nginx as their web server. But there's a dilemma with this concept that I'm presenting you here, that the client is always a PC and the server is always some mysterious device stuffed away in a data center. The reality is that our client does not always have to be a PC and our server does not always have to be a server. We have to look at really what the definition is of client and server when we're talking about application layer protocols. So if we take a look at what a client is simply a device running client software used to communicate with a server or service on the same or another device. So our client is going to be some kind of software, and that software we're going to use to talk to some server or service, effectively the same thing here. And those servers can live on the same device as the client if we want. Typically, they're not. Typically, our server lives on some other device someplace else on our network. So really, again, the client is the device that's running client software that can communicate with the server. The server is a device running a service, and that service is some type of program or application that is listening for the client communication requests. So the server is literally sitting there with its ear open saying, hey, some client, talk to me, please. The terminology we'll often use in data networking is that our services or our servers listen on a TCP or UDP port number for client requests. So we have servers listening on this port number, waiting for some clients to communicate with it via TCP or UDP, depending upon what layer 4 protocol the application layer protocol uses. So the client is software, the server is software, and they're used to communicate from one to the other. So what does this mean? It means that what can be a client and what can be a server? Well, our PC, server, router, or switch, those can all be clients. The PC, server, router, and switch, they can also all be servers, and they serve different roles for different purposes at different times. We have to be aware of this when we're setting up and building and working with application layer protocols, that sometimes our device is a server, sometimes our device is a client, and sometimes our device is both. So let's take a look at one of these cases. So here we have a router and a PC, and we want to transfer a file, this binary file or the operating system file for the router. We want to transfer it from the PC to the router. To do that, we turn on a TFTP server on the PC. We've done this in a previous video when we did the router configuration. We turned on that TFTP server and we put our bin file, which is the operating system file for the router. Then our router acted as a client and said, hey, send me that file. And the server sent the file to the client. For a different purpose, though, we can actually use TFTP in the reverse direction and switch the roles of the client and the server. So here, let's say that there is some configuration file in the router, like the startup config file or the running config file. and we want to grab that file off the router and transfer it to the PC for backup. Well, in this case now, the router is acting as the TFTP server, the PC is acting as the TFTP client, and we send the file from the router to the PC. When we look at Telnet or SSH, in this case, the router is the server, the PC is the client. So the client opens up some software like PuTTY and then sends the Telnet or SSH request to the router's Telnet or SSH server. So the router is actually listening on port 23 for Telnet or 22 for SSH, depending upon what's configured. We can also set up Telnet and SSH to a server, especially Linux servers that we often use to run all kinds of stuff. We're not going to actually have a GUI that we go into and modify configurations on Linux devices. Typically, we're SSHing into them. I know in my previous experience, our DNS servers were entirely run on Linux, and when we wanted to make modifications to them, we simply SSH'd into that server and made the changes to the DNS server via command line. We can also set up Telnet or SSH on a PC. So our PC could be a server. My intention of what I'm trying to show you here is that the device does not dictate whether it's a client or a server. The software running on the device dictates whether a device is a client or a server, and devices can be both clients and servers at the same time. We can literally set up an HTTP server on a PC. Windows has IIS built into it. All we have to do is enable it, and we can actually create a web page on our PC and have our PC listen on port 80 for HTTP requests. We can do the same thing with FTP. Now, Windows does have a built-in FTP server software. However, it's kind of junk and a real pain to configure, but it does have it built in. There's other softwares out there that are available that can do the same thing. So our PCs we can use as servers or as clients. Our routers act as servers and as clients, as do switches and other devices. So again, it is the software that's determining which device is which. So if we really examine this, it's the function that defines whether a device is a client or a server. The type of device does not define whether it's a client or a server.